Hello and welcome to Simeon's Toolbox talk on anchor tie testing. I'm Dave Burrows, I'm a senior consultant with Simeon. What you'll notice at the bottom of your screen, or maybe at the top of your screen, there's a little Q&A chat box. If you have any questions throughout the presentation, please just type the questions in here and I'll aim to answer them as we go through the PowerPoint. Further than that, I'll have a look and there'll be some time at the end as well to answer any questions you may have. Okay, so what we're going to cover today are reducing the risk, so how can we reduce the risk using ties, different types of stability measures, the anchor testing guidance, what types we need to test, the types of anchor ties and the types of tests that we can do, the testing procedure, and also what we need to do in terms of reporting the test results. Like I said, there's a slide at the end where you'll have opportunity to ask any questions that you may have. So, what types of stability measures are there? And why do we need to do it? Well, all scaffolding, whether it's tube and fitting scaffolding or system scaffold, it's got to be erected securely, and generally it's got to be tied to prevent it collapse, overturning, any uplift. These are generally referred to as stability measures, so in TG20 and generally on scaffold designs it'll be known as stability measures. So various ways we can achieve that. So there's ties to the building facade or other structures, so that's using drilled anchors or physical ties. There's freestanding scaffolds, so that's scaffolds that rely on the self-weight and their base to height ratio. So what we'd know generally would be towers, bird cages, that type of structure. Okay. Other measures that we can use are rakers, buttressing, Kentledge weight, ground anchors, various ways to keep a scaffold stable. Essentially, if you can stop a scaffold from moving, it isn't going to fall over. Okay, so what can we do to reduce the risk? Well, few various methods, but the stability of that scaffold structure is generally dependent upon, amongst other things, is the suitability and security of those stability measures that are installed. That security depends on several factors. So the correct type of stability measure being selected. So let's assess it before we put that scaffold up. The correct installation of that chosen stability method, and also testing of that chosen stability method where it's necessary. So that would be a drilled anchor tie. Okay, lots of anchor testing guidance about. The NASC, so that's the National Access and Scaffolding Confederation, they've produced a full series of guidance notes, and one of those guidance notes is what's known as TG419. So that's anchorage systems for scaffolding. Now, it's quite an in-depth document. It's around 34 pages. There's a lot of information there in terms of securing scaffolds, the types of ties that you can use. That guidance has been developed in association with the Construction Fixings Association, so the CFA. It gives you guidance on the selection, installation and testing of drilled anchors for scaffolding. So that will be into masonry, so concrete, blockwork, stone, brickwork. It also does give you some brief details on tying into steelwork and timber structures as well. Within that document in TG419, there is lots of correct installation guidance, so the types of tie that you can use and the suitability of the base material that they can be used in. There's a little graphic on that and shows you what types of ties are good for the base material. As well as TG419, there's also a lot of information. There's a full section on scaffold ties within the NASC guidance document, TG2013. So that's the operational guide. It's a good practice for tubing fitting scaffolding. So types of tie to test. What do we need to test? Well, essentially all types of drilled anchors. If you use drilled anchors to tie that scaffold into a building, those anchors do need to be tested. Okay, little example of some of the ties. So the traditional, commonly known as a ring bolt or hilty ring, that's a drop-in type anchor that's secured to the building, and that's probably the most traditional method of tying scaffolds. A lot more different methods out in the market, but probably one of the most commonly used ones these days, certainly for a general purpose tie, would be the nylon plug and the screw-in eyes. But all of those fall into the category of types of tie that do need to be tested. Also, all those types of ties need to be tested in each different type of base material. So if the building you're erecting a scaffold on has 3 different types of base material, so if it has stonework, blockwork and brickwork, these ties need testing in each one of those base materials just to make sure that they can all sustain the safe working load of the tie. So what types of tests can we do? Well, there's 2 types of tests. There's preliminary tests. So these are the types of tests that carried out whenever there's any doubt about the suitability of the base material or the recommended low capacity of the proposed anchor. All tie manufacturers give you a maximum safe working load of their tie or their anchor. Most manufacturers will give you that safe working load if it's in structural concrete. So I would say 95 to 99% of those ties that you use will not have data for the type of material that you're tying into. So prelim tests should be done prior to starting any job. Okay. The other type of tie test is a proof test. So these are done on anchors that are actually used to secure the scaffold. So the prelim tests are done on anchors that are sacrificial. So you do them before you start the scaffold. Proof tests are done on ties that are used to actually secure the scaffold to the structure. Okay. And that's basically to check that anchors have been used in the job, that they've been installed correctly. So we do a test a percentage of those. So talk a little bit more in depth about preliminary tests. Okay, so generally, in terms of preliminary tests, you would test a sample, 5 sample anchors in each different type of base material. Okay, the test load would be 2 times the working load, but that can go up to 3 times the working load for some plastic plugs. Nylon anchors, so the nylon plugs that are made from PA6 or PA66, don't need to be tested to 3 times the working load. They can be treated as normal ties and just tested to 2 times. Okay, you would find what your plugs are made out of from the manufacturer's data. So the manufacturer's instructions will give you that information. So give you a couple of examples of how it works. So if it's a very light duty tie, so 2.7 kilonewtons or less, the preliminary test load, so that's 2 times, would be 5.4 kilonewtons. Okay. If you're using a nylon plug that needs testing to 3 times the working load, that would be 8.1. Okay. A light duty tie is 3.5 kilonewtons or less. The prelim test load times 2 will be 7 kilonewtons. If it's times 3, so if it's a nylon plug, it'd be 10.5. Okay. Standard duty, 6.1 kilonewtons or less. Prelim load would be 12.2. Generally, that type of loading would be unsuitable for nylon anchors. Likewise, with your standard duty B and your heavy duty ties, they would generally be a load that would be unsuitable for nylon anchors, purely because of the test load, 18.2 kilonewtons. Most nylon anchors would be a maximum loading of 10 kilonewtons. in structural concrete. Okay, so there's a test load. What do we need to do to get them to pass? So what's the criteria? So essentially, if all test anchors take the test load without slip and without any visual movement, and they'll hold the load that's been applied on the dial on your pull testing machine, that's good. That essentially means that they've passed that preliminary test. Failure, so if you're applying your test load and that anchor starts to fly at the wall, or it won't sustain that load that you've applied with your test machine, there is some calculation that you can do, which is recorded in more detail within TG419. Our advice would be, if you're unsure, refer that back to your line manager, and I would suggest that gets discussed with a design engineer who can provide you further guidance for that. Okay, so that's prelim tests or preliminary tests. Following on from that, once you've done your preliminary tests, your scaffold's good to go. They would always be done prior to starting any scaffold. Okay, once you've done that, you know what anchors you can use, you move on to proof tests. And once your scaffold's up, proof tests are undertaken on ties that are actually used to secure the scaffold to the structure. Okay, should be carried out on all projects. Okay, the test load for that is the sample anchors that you test will be tested to 1.25 times the working load. There's your example. If it's a light duty tie, 3.5 kilonewtons, the test load, the proved test load, will be 4.4 kilonewtons. A standard duty tie at 6.1, your test load will be 7.6, and so on and so forth. Okay, how many anchors do we need to test? Well, minimum of 3 anchors. You've got to test a minimum of 3 anchors and at least 5%, so 1 in 20. Generally, that would be increased to 1 in 10 or 10% of the ties for ties installed into brickwork. Okay. Pass criteria: no significant movement of the anchors apparent, and again that it'll sustain that imposed load that you've put on the tie with the test machine, you know, that it doesn't drop while you're checking, and that it maintains that loading that you've applied. So what happens if we get a fail? Well, if we have a fail, so 1 failure, you double the testing rate to 1 in 10 and at least 6. If you have 2 failures, double again to 1 in 5 or at least 12. More than 2 failures, you need to test 100% of the ties, because if you've got more than 2 failures, there's either an issue with the installation method or the substrate. Okay. We would also recommend at this point that you review the fixing specification and the installation method. So that would warrant probably some further investigation. Okay, again, you can always go back to your design engineer with that and ask them, you know, for advice and guidance on what's going wrong. So, test procedure. Well, got to be carried out by a suitably competent person. So we'd always recommend that they've been trained and certified to undertake that. Swimming can offer that course as well, half-day course. You can get that information from our website. So, providing that you've got a suitably competent personnel, so they're trained, ideally it should be somebody doing the testing that hasn't actually installed the fixings. Those tests have got to be done using a test meter, so various different makes out there. There's Hilti, there's Hydrojaws, there's a Big Ben one. So various options, various different options. There's a sort of, that's a Hilti one. That's probably a standard scaffolding test kit. So in there you've got all the different types of adapter that you can use. They would cover all types of scaffold tie. So once you've got your pull tester, everything's there. That pull tester should be calibrated within the last 12 months. So it should have been tested and calibrated, and you should have a certificate with that pull tester saying when the last calibration date was. So All anchors that have been proof tested should be clearly identified with a tag. So there's an example. Obviously, loads of different types of tag on the market. Well, that's quite a good example of a tie tag. So tells users of the scaffold that it's a structural tie and that they shouldn't remove that tie or the tag. And it also gives you on there the name of the person that's done the test, the site, when that test was done, and also on there you record the actual working load of the tie and the actual tie load that you've tested it to. Okay, so it'd be good practice to certainly put that on any tie that's been tested. We would recommend that you have a minimum of a scaffold tie, do not remove tag on your other ties as well. Okay, that equipment should apply the load to the anchor, okay, and it's got to be arranged in such a way that the reaction loads are sufficiently far enough from the anchor so as not to influence the result. So that would be the positioning. So on the next slide, give you a better idea and a real-time picture. So as you can see, the top feet are on one brick. You've got your anchor tie in the middle and your bottom foot is on the course below. So essentially what that does is it leaves the brickwork and the tie itself free from any interference. So that when you apply the load, so that's your top feet there, and there your bottom one. Essentially the brick in the middle isn't stopped from pulling out. So it gives you a true reflection of what loading that brickwork will take and the actual anchor will take. Okay, so once you've done these and you've completed all your tests, okay, you should record these in a pull test report. So the result and the location of each tie that's been tested as well. So there's an example of a pull test report. That allows you to record obviously the client and site where you've done the pull test, what type of material you've been testing it in, what anchors that you're using. It allows you to record the test equipment and the serial number, so that the date it was last calibrated, and then in there how many anchors you've tested, how many anchors are in the scaffold, the allowable load and the proof test load. There is a section there to record the preliminary test if it's required, and then the bottom section of that is to record the proof test. So obviously it gives you a number of the anchor that's been tested. You can record a location of where it is. So an example would be east elevation, second lift, fourth tie along. Okay. Allows you to record the test result, and then there's a little section for any notes. So maybe that could be recorded that there was no significant movement, or you know, tie moved, tie failed, whichever, whatever you need to record in there. Okay. Then at the bottom you've got who did the test, who it was witnessed by, and then signatures, basically time on site, time off site, and signatures. Okay. So we'll move on to any questions. So if there is questions that haven't been answered throughout the presentation, you know, now is your time to get in there. If you use the question and answer feature at the bottom, I will endeavour to answer every question that you've got. Okay. Thanks for listening. Thanks for your time. Also, just a quick note on our social media feeds. So if you are interested and you want to get updates on industry guidance and dates for our next webinar sessions, that's there on that last slide that we're showing. So all our Facebook, Twitter, Instagram, LinkedIn and YouTube channels. Okay. Thank you. Thanks for listening. I'll see you again soon.